Why is this? Why are food products worst? The worst category. Have a look at this graph. This shows various types of resources down here and divided into categories, how much is used. If you take the top one, this whole bar here shows all the expenditure of fresh water. If you have a look on the white bar in the middle, you will see that food products by far consume the highest amount of fresh water of any type of activity. Land use, similarly, 50–60% of land use is associated with food products. Not so much noise or smog associated with food products, but certainly eutrophication, that is the organic pollution of lakes and waters. 60% of that is due to food products. Toxicity, acidification, climate, and energy. I think it should be very clear to see from this graph why food products are as bad as they are, why they rank lowest or highest in this study that I just showed. So, how do we determine this? How can we use this to try and identify the bad products and also identify the good products, of course? Because in the shop, we can buy a bottle of ketchup here, and on the same shelf next to it, there's another bottle of ketchup. And these seem identical to us, and we might expect them to have the same environmental load, but they haven't. These two identical bottles may come from two different production plants, where one plant is very ecologically sound and the other is not. That is the exception. But even if they come from the same plant, these two may come from completely different ingredients batches. The tomatoes and also the salt and the sugar that's in here may be completely different from the tomatoes in this one, or the salt and sugar in this one. They may, even if they have the same ingredients, they may come from different production batches. One of them produced during the day, one of them during the night, one produced on one modern machine, which is very eco-efficient, another produced on an old machine, not very eco-efficient. They certainly may have different production dates and use-by dates, and even if all these above are the same, they may have taken different transport routes. One of them transported by ship, the other by truck. And even if they take the same transport route, they may have completely different temperature histories. One of them consuming a lot of energy to maintain the temperature, the other one not consuming a lot of energy. So the point I'm making here is seemingly identical products may and will also in practice have very different environmental load. And it's obviously very complicated for us to try. We have a real challenge in front of us if we're trying to keep track of all the environmental load related to this this box as opposed to this box. A practical example of the difference is from a study in the Netherlands where they looked on the environmental load specifically for tomatoes. And I suspect they were hoping to prove that homegrown tomatoes in the Netherlands were far more environmentally friendly than the imported tomatoes for Spain. Unfortunately, if you see contribution to global warming, these are the Dutch homegrown tomatoes. This is in ground in a heating house. This is in ground outside. This is on substrate in a heating house. And if you see the contribution to global warming is fairly bad, especially for those grown in the greenhouses. The substrate one is comparable to these tomatoes, which are the ones imported from Spain. So you'll see here the blue bit is the cultivation part, which is where they use a lot more, where there's more environmental load on the Dutch tomatoes, a lot less in Spain, which is compensated by the transport, which is obviously a lot more for the ones from Spain. They had to be transported 1,825 kilometers. This is with relation to global warming, but when they studied toxicity, that is the emissions, the toxins that are released into the environment, you will see that the homegrown Dutch tomatoes were far better or had far lower environmental load than the ones imported from Spain. These two different types of tomatoes could very well be in those two boxes of ketchup that you just saw. And that will mean that the two seemingly identical boxes could have completely different environmental load. Now, sustainability is not only about environmental load. So I'll give you one other example, which is a more generic view of sustainability. And that's very related to some of the other presentations we've seen here. It's the production of salmon farming. What I'm showing you here is a list distributed by WWF with respect to what are the sustainability attributes for salmon production. Specifically, what will an environmentally conscious consumer be interested in? And I'm not going to go through this in detail. I'm just going to show you it's quite a lot. It's where is it, who is it certified, what type of certification, area use, technology use according to standard or not, escape history from the farm, lice treatment, medicine treatment, physical damage, mortality, impregnation material, fish density in cage. This, according to WWF, this is a list of the sustainability parameters relevant to document and disseminate from the fish farm. But as you well know, the fish farm is not the whole chain. There are also a bunch of parameters relating to the feed, which is relevant. There are similar parameters for the slaughterhouse, for the smokehouse, and for the transport and finished product. Now, I won't go through this in detail, as I said, but the point I'm making is this is a lot of information. It's a real challenge to try and keep track of the origin of the tomatoes, the transportation routes, all these parameters for salmon production and so on. So what we need is a really good system for taking care of the information that is in the system. Luckily, we have a solution for that, and the solution is called traceability. Also for traceability, we have many definitions. Probably the most practical one for our purposes is the one in the old ISO 8402 document, where it says that traceability is the ability to trace the history, application, or location of an entity by means of recorded identifications. And the ISO definition adds that when it comes to products, which it does for our purposes, it may relate to origin of materials and parts, the product processing history, and distribution and location of the product after delivery. Now, if my previous slides about sustainability and environmental load showed you the problem, what I'm showing you now is something of the solution. We need a system like this to take care of these, to record these parameters, these environmental load values, if we're going to try and distinguish the good products from the bad products. A small point about traceability, because it's often a misunderstood concept. Traceability is not the name of the data itself. Traceability is the name of the system you use to keep track of data. I have visited a lot of food producers, and most of them in the seafood industry, and I've seen a lot of varying degrees of good traceability systems. A good traceability system does not necessarily mean recording a lot of data, but it means always be systematic when you record the data. The worst companies with respect to traceability are those who record very important data on small yellow sticky notes. If we find that when we go on these process mappings, as we call them, we know that there's going to be trouble, because although the data may be there, it's not in any way in a system or in a database. What traceability does refer to is your systematic ability to access the data you have stored. If you have a good traceability system, you should be able to actually access your data at any point in time, quickly, unambiguously, and accumulated on any level. An illustration that we often use. Here is the salmon chain in the background that you see. Here's the salmon farm, here's the slaughtering, here's the smoking, and here's the consumption of it. And if you can imagine these carriages here, they don't contain salmon in this illustration. What they contain is data. In this carriage here, we have all the data, all the systematic recordings that the definition talks about. So in this carriage, we recorded everything that is going on the salmon farm. In this carriage, we have recorded everything that's going on in the slaughterhouse, in the smokehouse, and at the retailer.